Donc un peu dans la même série, il y a un texte, il y a un poème chanson en anglais, écrit par Tom Apostol, et que Ingrid et Nicolas vont nous interpréter, je ne sais pas si c'est immédiatement, dans quelques minutes. Merci.
Where are the zeros of zeta of S? GFB Riemann has made a good guess. They're all on the critical line, say he, and their density is 1 over 2 pi log t. This statement of Riemann's has been like a trigger, and many good men with vim and with vigor have attempted to find, with mathematical rigor, what happens to zeta as the mot t gets bigger. The efforts of Landau and Bohr and Kramer, Hardy and Littlewood and Titchmarsh are there. In spite of their effort and skill and finesse in locating the zeros, there's been no success. In 1914, G.H. Hardy did find an infinite number that lie on the line. His theorem, however, won't rule out the case. There might be a zero in some other place. Let p be the function of pi minus lie. The order of p is not known for x high. If the square root of x times log we could know, then Riemann's conjecture would surely be so. So, related to this is another enigma concerning the Lindelhof function mu sigma, which measures the growth in the critical strip on the numbers of zeros it gives us a grip. But nobody can tell us how this function behaves. Connexity can tell us that it has no waves. Lindelhof said that the shape of its graph is constant when sigma is more than 1/2. So where are the zeros of the zeta of S? We must know exactly. It won't do to guess. In order to strengthen the prime number theorem, the integral's contour must not go nearer. Andre Well has improved on Riemann's fine guess by using a fancier zeta of S. He proves that the zeros are where they should be, provided that the characteristic
is P.
Thank you. There's a moral to draw from this sad tale of woe, which every young genius amongst you must know. If you tackle a problem and you seem to get stuck, just take it, mode P, and you'll have better luck. La barde mystérieuse se dévoila à Oppostad en 1990. Il n'était pas autre que le topologue algébriste Saunders MacLean. 9 ans plus tard, à l'occasion de la conférence Catégorie Théorie tenue en son honneur pour ses 90 ans à Coimbra en Portugal, pendant le banquet, MacLean, drapé en cape ténébreuse, interpréta la ballade y en ajoutant quelques couplets que je vais vous lire. Vous êtes prêts? What fractions of zeros on lines will be found when mode T is kept below some given ground? Does the fraction whatever stay bounded below as the bound on mode T is permitted to grow? The efforts of Selberg did finally banish all fears that the fraction might possibly vanish. It stays bounded below, which is just as it should, but the bound he determined was not very good. Norm Levinson managed to show better yet. A 2-to-1 odds. It would be a good bet. If over a 0 you happened to trip, it would lie on the line and not just in the strip. Levinson tried in a classical way. Weil brought modular means into play. Atiyah then left, and Paul Kayan quit. So there's no proof at all that will it fit. So now we must study this subject anew. Stair points out manifold things that it makes true. A medal might be the reward in this quest, for Riemann's conjecture is surely
the
best.